I listened to the radio. When I was a kid, it was a long time ago, we had big transistor radios, big long antennas, and then, then things started changing. We got into 8-track players, cassettes, and finally CD players. And then along came cable TV. We had things like MTV, the streaming stuff. And the streaming services, we had Spotify, Apple Music, Pandora. And of those, some are better than others, in my opinion, some pros and cons. But I think the best pro of all of them is no commercials. Well, you guys ain't that lucky. This is your commercial. Anyway, I'll tell you a little bit about Bamakosh. There's about 4,000 GM dealers in the country, a little over 4,000. Out of that, 316 are wholesale dealers. And what that means is that we qualify for some really cool programs that we can give to you guys, like price matching on aftermarket sheet metal, the Mars pricing through mechanical parts, the mechanical repair service, I think what Mars stands for. But a lot of those times, a lot of situations on those, when you place an order through Repair Link or Collision Link, you can buy parts cheaper than I can buy them from GM. So it really is serious, pretty serious business. Hope you guys are all taking advantage of that. One of the things I wanted to talk about was that one of the things that's changed for us is that we have now become a Lucas Oil distributor too. And if you notice all our Lucas products over here. Lucas is a well-respected, recognized name, and they have we've been very successful selling a lot of the oil additives, transmission fixes, all the stuff that they've got. But one of the coolest things is that big rack over there with the oil bibs in it, called bag in a box, it's a bib. 6 gallons of oil, and we've got 020, 530, 1540, you name it. They've got side-by-side oil over there. We've got motorcycle oil, we've got rear differential oil, fluid, you got transmission fluid. So if you've got European oil, if you have every once in a while you got some European cars coming in, so instead of having a whole bunch of quarts of stuff that it's a lot of waste and it's expensive. This is a lot more economical way to do that. And Bamakosh deals right now, we got a deal going. If you buy 6 bibs, you get the rack and the jugs for free. So, not a bad deal. A lot of people using it. So, if you haven't looked at it, please do. The other thing we have over here on display is our wrap box. Has anybody used a wrap box?
No, yeah.
Yeah. RAP stands for Rapid Access Programming, or Remote Access Programming. There's a company out of Detroit that they sit around, and what they do is they will program your vehicle with that box. You plug it in, hook everything up to it, call them for an appointment. They'll call you back at 2 o'clock or whenever your appointment is, and then they will have you turn the key on and off and do some of that stuff while they sit there and program from Detroit. And I think they charge $150 to do the programming. We don't charge anything. We charge you a deposit that you get back afterwards. So we basically loan it out. You buy a module from us, we loan it out to you. Okay?
Did you say if you buy modules from you?
It works on Ford and Chrysler and stuff like that. I only have one box, so I try to limit it, to our customers. We used to have 2. Yeah, we don't. We had one that actually we were borrowing from somebody else, and then he started getting bills for it. I guess they weren't doing it right or something. So you have to use your credit card on this. You can't charge it to us. But yeah, I still like to get. Sometimes we need 2, sometimes we need 3. We were actually there's 3 prototype dealers in the country that were tested these out for. And one time we had probably half a dozen or more. 8 of them. 8 of them. And 8 of them that we loaned out and stuff to let everybody use. And they got a lot of good information from that. So, something we continued. If we don't rent it out enough, it doesn't get used enough. We pay rent on it, so we just keep it for you guys. So, yes, you can use it for a Chrysler or a Ford, but we need to be very careful for that because then I can't give somebody else. So, anyway, wanted to introduce my staff to you guys, and I'm gonna go down the list, even though a lot of these guys aren't here. Phil Fancher is one of our inside sales guys, and he's on vacation. Kip Rouse is the next inside sales guy, and he's getting ready for turkey hunting tomorrow. Nolan Stuber is not here. He's bowling or something. But of the guys that couldn't come up with an excuse not to be here, we've got Parker and Luke. And those are my inside sales guys. The outside sales guys, we got Carl Bowman and Larry Kane. And our warehousing distribution, we got Bo Neef. And shipping receiving, Kevin Paris. And my administrative assistant is Julie Miller. She's the one who puts all this stuff together, so thank you, Julie. Drivers, we've got Monica and Jacob here tonight. And I think Terry and everybody else has not made it in tonight. So anyway, with that, I kind of wanted to introduce that to you. You know, a lot of times we talk to so many people on the phone all the time or computer stuff. We don't put names and faces together sometimes. Well, you're an exception. which we try to figure out. Anyway, thanks again for coming with that, and we'll turn it over to Rusty, and he'll get started on it.
All right, give these guys a hand. All right, so my name's Rusty, like he said. I think some of you guys were here Tuesday night to listen to me preach. Some of you guys weren't. I've met a few guys before. But again, my name's Rusty Sampsel. If you Google that, everything you see for the first 5 pages on Google is probably me. My name's unique enough. All except that felony stuff, all right? Felony stuff. I was never convicted, all right? All right? We all right with that? So people ask me how long I've been working on cars, all right? So this car is my car. It used to be my dad's car. And that's a picture of my dad's car, that car I just showed you. And that's me. So when people ask me how long I've been working on cars, I point to that picture right there. So the kind of funny thing is that I still have that car. I even still have that wrench. And I even still have that haircut. Hopefully my diaper's not loaded like it was then. All right. So a little more about me, I guess. Like I said, I've been working on stuff a long time. I worked in independent shops like you guys have. I did work at GM dealerships for a while. Bounced around there. I'm ASC certified Master Tech, A1 through A9 plus L1, L2, and L1, L3, and L4. Back in the day when I was still working at dealers, I was Chevrolet Master Technician and Oldsmobile Master Technician, which they don't even make Oldsmobiles anymore. And then, so I did that in Pennsylvania. That's where I grew up, and then got my funny accent. And then I ended up, the late 90s, I left the dealership, moved to Michigan, and went to the GM Technical Assistance Center. You know what that is? That's where the GM dealership techs can call and get help with repairing vehicles. So at that time, late 90s, early 2000s, there wasn't a lot of internet action. We were doing it all over the phone. There was probably about it fluctuated between about 160 to 180 guys there, mostly guys taking calls from all over the country. And we would take calls, upwards of 1 million calls a year from all over actually North America, really. And so I did that for several years and kind of worked my way up from answering the phone to a liaison between that call center and GM powertrain engineering. And I was mostly in the powertrain side for the most part. That's my strong suit. And I was responsible for rear-wheel drive vehicles from the flywheel back. So it's basically automatic and manual transmission stuff, transfer cases, front and rear drive shaft, which was a lot of vibration stuff we did, and front and rear axles. And did that for a few years, and then because of my hot rodding background, I ended up getting involved with a portion of GM back then it was called GM Performance Parts, which had some crate engine stuff that they sold and still sell back then, but they wanted to get into more powertrain stuff. They wanted to add transmissions and stuff. That's kind of where I came in. And so I started doing that. That actually moved me to the GM Proving Grounds in Milford, Michigan, which is a pretty cool place to work. I ended up working there for about a decade, really. And so I was, pretty much everything is in the Chevy Performance catalog. It's 4-speed auto, 6-speed auto, or 6-speed manual I had my hands on or did for a long time. And getting to the late, around 2017, I was racing this car actually, and we were traveling, me and my wife, we were empty nesters, and we were traveling from Michigan down into the southern part of the country. And it'd be cold in March and November. We would be out trying to race and leaving in the snow and everything, and then going down to beautiful weather, and then going back up to the snow. And finally my wife said to me, "Why are we living in Michigan?" And I said, "Well, it's this job thing, you know, kind of keeping me here." And so long story short, she ended up getting in a car accident in a snowstorm one night, and she didn't get hurt, but that kind of, you can imagine where we went from there. So I ended up started working for GM. I ended up becoming a parts rep. I left GM Performance Parts and went to, or Chevy Performance I should say, and went to, became a parts rep. And we moved from Oklahoma to, or excuse me, from Michigan to Oklahoma. And I was there about a year. I was a parts rep there for about a year, and then they moved me into another position with a fleet parts rep actually. And then my territory got a little bigger. I took over Texas and Oklahoma. They moved me to Texas when I did that. And then the pandemic hit, and that kind of changed everything, and the job kind of got kind of tough to do. And I knew a lot of guys in the performance industry that took off. When the pandemic hit, everybody was working on their hot rods in their garage and everything, and they were rocking. And so I got pulled away out of GM and went to a company called Edelbrock. And Edelbrock was moving from California to merge with some companies in Mississippi, in Tennessee, comp cams and TCI transmissions and a few other fast fuel injection, all those guys. And I started working for them, and then the economy kind of started catching up. I moved again. Me and my wife moved 3 times in 4 years from Michigan to Oklahoma, Oklahoma to Texas, Texas to Mississippi, and still where I'm at. And with them for a little bit, and then I started getting nervous about the whole economy thing and everything, and I knew about this job. I knew, if you guys know Lee Hamler, he used to do a lot of training here, and I'm friends with him, knew him for years. And when I did the parts rep stuff, I worked with him a lot, and I always thought about doing this job. And I did a lot of training when I was at TAC, and when I was in, as a parts rep even, and when I worked at Chevy Performance, and when I worked at Edelbrock, I did a lot of it. I like doing that. And I thought, man, to do that full time would be really cool. So I ended up starting this job, picked up bits, almost 2 years now I think I've been doing this. So that's how I got here in Columbia, Missouri. Where we're at? Columbia, Missouri, on a Thursday night. All right. So that's me. So you guys are here to, I hope this is why you're here, is to learn about active and dynamic fuel management systems. What the hell is that, right? I think somebody was asking me here earlier, what the hell is that? So,
it was something that they
years ago
all right.
they shouldn't have brought back. So we talk about the mission statement, but that's pretty common, right? We're trying to treat, that's the idea behind this whole deal is, right? We try to come up with some training that you guys can use to help you fix cars and make more money, right? That's what we do. So we're going to talk about active dynamic fuel systems, but it's the, displacement on demand might be another word for it. Cylinder deactivations, another word for it. And we're going to talk about the repairs and the diagnostic stuff a little bit, and some service tips, that kind of thing. But we'll talk about the difference between the active and the dynamic as well. So caution statement, we always throw that up there, just because you come to this class doesn't mean you know everything. Always read service information, make sure you got the right tools, equipment, right parts, make sure you use right service procedures, don't get hurt. And then we use Mr. Pro Demand for stuff we don't have access to. Like we got all stuff for GM stuff, but a lot of times we try to cover other manufacturers. This particular class here is pretty much all kind of GM deal, so doesn't really apply. All right, so let's talk about it. What is it? What are ADFM? I mentioned that earlier, right? So this is their definition here. ADFM is active dynamic fuel management. It's often referred to as cylinder deactivation. Of course, we'll talk about the difference between active, which is what you guys have seen, and the dynamic, which you may or may not have seen. So what they're doing, and a couple of things about this. I forgot to mention. Number one, I wear hearing aids, so this room's pretty good. I can usually hear pretty good, but you may have to speak up if you have any questions or anything. This is super informal. Stop me anytime. You know, if you get questions or whatever, don't wait. Get my attention. We'll talk about whatever you got. And then another thing about this presentation, I want to let you know ahead of time, is there's a lot of redundancy in here. I don't know why they did it, but it seems like there's a lot of slides that have the same stuff on it over and over, and I'm not going to bore you guys with the same stuff over and over. So you might notice me kind of blasting through a couple slides, and that's why, right? I'll give you the meat of this. I'm not here to keep you here all night either, right? I want to kind of get you guys what you need to know and keep you going, you know, get you back home. We can do like a 4-minute video. You could have some barbecue, a 4-minute video, and be home in time to watch Wheel of Fortune, right? But a little bit longer than that. All right. So the idea of this, what their idea was, the main one is probably the fuel economy, right? And emissions. And working for the OE, I can tell you, that's their number 1 and number 2 goal, and I'm not sure in which order it is. The fuel economy and fuel emissions. It's all pushed by the government, right? Performance, we'll talk about why they say performance up there. You think about cylinder deactivation, how does that improve performance? I tend to agree with you, but I'll explain what their theory is on that as we get through this. So, all right. So again, this is what we're doing, right? It's cylinder deactivations, again, I told you, and it does this. So if you guys have driven any of these, I'm sure you've messed with them a little bit. Somewhat.
Yeah.
Yeah. So when does it do it? When it goes into cylinder? It doesn't do it like an idle, right? It doesn't do it wide open throttle. It doesn't, you know, it's mostly at what? Just a light cruise running down the road, right? So if you really think about that, you know, most of the ones you've dealt with are probably V8, I'm guessing. We do it in some of the V6 stuff, and even on some of the 4-cylinder stuff I'll show you. But mostly what you guys have probably seen issues with is V8 stuff. But if you think about it, running down this, you know, the interstate out here, I-70 at steady state speed, you're barely into the throttle. You really need 8 cylinders running down the road, right? And that's the idea, is they can actually pull the, you know, shut a couple of those cylinders down or several of those cylinders down and then work the other ones a little harder, and it's actually more efficient that way. Actually, from a fuel economy and emission standpoint, it actually works better. So that's the performance portion of it that they're talking about, right? But that's when they're doing it, right? Partial load engine is when you're going to get into this cylinder deactivation stuff, okay? So, you know, ideally they want this to happen. It shifts into 4-cylinder mode and 8-cylinder mode seamlessly. And that's kind of arguable as well, right? So, again, it's going to look for all the different things. So they program that all in there. We'll get into that a little bit later, but there's a lot of different criteria that has to be met before it'll actually go into the cylinder deactivation mode, right? So when once any of that occurs, it'll go kick back in. If you step into the throttle, or you know, you can do a lot of things to turn it off, right, as you're driving. All right. So I kind of mentioned some of this. What's the benefits of it? It's already mentioned this earlier too. Increased fuel economy, reduced emissions, improved performance. So efficient combustion is, we're going to try to help this. This is, again, one of the big deals that they're after, right? They want to improve emissions. So here are the tailpipe emissions that they're worried about. We're going to talk about them in a minute. So like I said, it's a little bit redundant. All right. So let's get into engine operation a little bit. So we got to know how engines work. I'm hoping you guys are pretty up on that, but we're going to go over it anyhow a little bit. I'll try to
Put the key in the ignition and turn it, and it works.
Yeah, but we're going to get a little deeper than that. All right. So we gotta understand what's happening. So understand what's going on. I mean, and that's another thing. I teach by the way I like to learn. So I spend a lot of time when I'm teaching, telling everybody, explaining how stuff works, because that's how I know how to fix it. If I don't know how it works, you're shooting in the dark, right? So mostly what we're going to talk about tonight is how this stuff is supposed to work. And we'll get into a little bit of the other stuff afterwards. So I'm going to blow these all on the screen here, but everybody heard all these terms, I'm sure, right? Everybody knows what a block is, pistons and rods. We won't talk about block very much. We're going to talk about pistons some. We'll talk about crankshaft, and barely. Time and chain stuff a little bit. Camshafts we'll talk about quite a bit. Cylinder heads, some of that stuff we're going to talk about, but the big thing we're probably going to talk about a lot is valve train and its dull deal. So, I'm hoping you guys got a pretty good understanding of that. Anybody got questions on what any of this is? I'm hoping not. All right. So let's talk about a couple questions for you. All right. So there's a question. How many degrees does a crankshaft rotate during one 4-stroke event? Cycle, I should say. Anybody know?
180.
No, more than that.
It's too many degrees.
So, a complete 4-cycle event.
360 plus times 2.
Crankshaft. How many times the crankshaft spin?
Good, twice.
It's twice. So how many degrees is one rotation?
360.
How many degrees is two
So
rotations?
720.
720. All right. Give that guy a water. All right. 720. So how many degrees does a camshaft rotate during that same cycle?
360.
360. Right. So it's half speed. Right. All right. So we're gonna go in. I'm just gonna put these out there too. So we're gonna. All right. Anybody familiar with these? With the hand up here.
Suck.
Intake,
Squeeze.
compression,
Bang.
yeah.
Blow.
Suck, squeeze, bang, and blow. I like that, right? This is the official story, but that's the way I go with it, right? Suck, squeeze, bang, and blow is the way it works, right? So, oh, wait a minute. There we go. Have to click on the right spot. So, what do we got here?
That's what she said.
One-cylinder engine? Is that a one-cylinder engine? What else can you tell me about it?
There's no timing chain.
Okay. Let's say it's there. Just can't say
It's
something
got a
back.
timing chain because it's got overhead cam.
It's overhead cam. That's one of the things I'm pointing at.
So it's gotta have a chain.
So it's a dual overhead cam, single-cylinder engine. What else you know about it? Kind of fuel it. Direct. Somebody said it. Direct injected. Right. So a direct injected, single-cylinder, dual overhead cam. Everybody agree with that?
Yeah.
And what's it going on here? The suck, squeeze, bang, and blow, right? And everybody's comfortable with that, because we're gonna talk more about that later. Do I need to go into that, or is everybody gonna,
No.
we're getting that, all right. Okay. All right, so valve timing is when, it's gonna be related to when the valve's open in relationship to crankshaft and piston movement, right? Is that fair? That's what I just said, all right? But when the old engines, before we got into, cam phasers and stuff like that, you basically just had a chain on there, right? And you lined the dots up or whatever you did, and that's the way it was, right? The valve timing never really changed, right, in the old days. Now, what do we got? We got all kind of phasers and stuff like that, especially on these. So let me ask you this question real quick. I think it's a good spot to ask it. You guys work on dual overhead cam engines, I'm sure, with phasers on them, right? So how many of those dual overhead cam engines, it's got separate intake and exhaust camshafts, have exhaust EGR valves on them? Right. Very rarely. That's not, I'm not gonna say they don't, but for the most part, when they got phasers on them, why is that?
Because it retards the exhaust cam timing.
They're basically moving the timing around, so instead of letting it come out and running it all the way back around and sucking it back in to do the EGR part of it, they're leaving it in there, is really what's happening, right? They're leaving the exhaust gas in the cylinder by changing cam time. Okay? So if it's fixed, like it used to be, there was a lot of limits, right? So it's kind of like camshafts. You know, we were in the camshaft business. I worked that deal for a while. So you always had to, if you're gonna have a solid chain design or even a belt design or whatever it is that doesn't have any phasers or anything, you got to pick a camshaft, and once you pick it, you're stuck with it. It's going to be that way at idle, and it's going to be that way at higher RPM, and you got to decide what you want, right? So the OE's always, right? So their position is these production vehicles are running down the road are at idle and light throttle way bigger percentage of time, way over 90% of the time. So they're going to focus mostly on that. You and I put an engine together, we're thinking about running at higher RPM, right? So we'll change some stuff, which we'll talk about in a minute. But again, the bottom line is you're giving up, if you put this performance camshaft in there, you're giving up some of that low speed, idle, smoothness and all that efficiency by going to try to, change that timing around, the valve timing around to make it perform the way you want it to. So, but bottom line is you're stuck with it, right? You give some up, you get some from the bottom, you take it away from the top, that kind of thing. So, let me go to the next one here. So everybody comfortable with what valve lift, right? We understand that, how far it comes off the valve, right? Or off the valve, off the seat. That's it, showing it right there. And then, of course, as cam turns around, that's what gives you your lift, right? And that's what it does. If you look at the cam lobe, there's how you can tell, right? The bigger the nose, the more lift you got. I don't think anybody here doesn't understand that, right? The height of that lobe influences that lift. And obviously taller lobes are higher lift, shorter lobes are lower lift. And then we also got rocker arms in there, right? rocker arm ratio can affect valve lift. So you can take the same camshaft, change the rocker arm ratio, and give it more or less valve lift, right? Everybody get that? Or am I losing you? So, if you look at your fulcrum here, as that cam comes up over that lobe, this is your rocker arm across here. It opens the valve so much, you get the ratio, that same cam lobe, that's a lot further on the other end over there, it actually gives you more valve lift doing that, right? That's kind of what you said there, right? So duration, what's the valve duration? Okay, and how do we measure that?
.50.
Yeah, but I mean, but as far as it's measured in what degrees?
Right.
Am I right?
Yeah.
But is that camshaft degrees or crankshaft degrees?
Camshaft degrees.
No,
No.
it's actually measured in crankshaft degrees.
Okay.
You can keep that in mind as well. All right. So, but they kind of give you the illustration here, right? The wider the lobe, the more the valve is off the seat, remains open, right? During that more degrees, crankshaft degrees, that valve is open. So you combine again, right here. Valve duration is measured in crankshaft rotation degrees, all right? And the cam lobe shape determines that duration. They're kind of like I said, they're showing you, look how many degrees you got on this one versus how many crankshaft degrees would be on the other one. All right. That's what I just said. Now, there's one other piece in here.
LSA.
Overlap. So when does it overlap? The suck, squeeze, bang, blow. When do you get overlap?
During the exhaust stroke.
I heard a couple things there, but I'm deaf. Was that somebody? What was it?
During the exhaust stroke.
So after what and before what? At the end of. End of blow just before suck, kind of. Is that it? You agree? The end of the exhaust stroke, it's not quite closing. They're opening the intake valve, right? Am I right or wrong? Overlap occurs at the end of the exhaust stroke and the beginning of the next intake stroke. Again, that's kind of back to what we were talking about, I mentioned earlier with EGR, right? That's kind of how they're doing. They're actually, you know, if they can move those lobes, that lobe center that you were talking about, you can spread them out, you know, and take some of the overlap out, or you can increase the overlap. You can affect how much exhaust gets pulled out of it when the exhaust valve is open, or how much it draws through.
So why would they affect the exhaust valve timing event instead of just, controlling the fuel?
Well, they kind of do both, right? The biggest thing, what they're doing with the phasers, I think that's where you're going with it.
Yeah, why would they negate the scavenging effect? Is my question.
Why
Why would they negate it? Why would they try to stop the scavenging effect?
Well, it depends on when. There's a whole nother. We're getting into a whole nother class that I've got. But as far as what it's trying, it affects the performance at different RPMs. So at low RPM, you don't want as much overlap as you do at higher RPM.
Right.
So it's about the efficiency, really. It's what you want that engine to do at that RPM is
Okay.
where you really need it.
So are they at lower RPMs? There's a different valve timing that should be for a maximum scavenging, but you're saying they want to keep the exhaust gases in there.
Yes, under certain loads.
Okay, that's just
So it's going to depend on the load.
yeah. That's
The RPM and load matter, and they can change it depending on what they want to accomplish on at that RPM and under that load.
Right.
That's kind of a loaded answer, but that's kind of the truth.
And all going back to emissions.
Yes, it all really, well, it's power and emissions. And reality is, if you make a really efficient engine, it makes good power. So they're after both. But I will tell you that emissions will win out over power if they have to pick one or the other. But ideally, what all of them are trying to do, I mean, it's not just GM, it's all the manufacturers trying to do the same thing. I mean, if you look at engines now, what are they building now? They're building wee little tiny turbocharged engines. That's most of what they're doing now, right?
I know. I saw a plasma engine on Google the other day.
Well, yeah, but I mean, if you look at in general, I mean, turbos are everywhere now, right? And so what they're doing, they found that those really small engines, they can make them at low speed and low torque, like we're just talking here, what we're getting into here with you running steady down the road. You can have this tiny little engine that can run very little fuel through it and make enough power to get down there. If all of a sudden you need power with this little engine, you just boost it.
But all that means nothing with an M8 head bolt.
Yeah, no. I hear you. So are we good with this? All right. So we got the lifter duration, and we got valve overlap. We got a little bit of cam timing going on. It sounds like you guys are pretty well on this. All right. Again, the impact of this valve overlap changes with engine RPM. That's why the phasers come into effect. So they can make a much more efficient, powerful engine over a lot more wider RPM, and not give up the rough idle, but still gain the top end and all that by using the phaser stuff. Which we're not really doing phasers today, but it's something to consider with all the stuff you guys do every day, right? And valve overlap will impact emissions, right? And that's the main reason they put the phasers in them. So again, this is a repeat what I've already talked about. All right. So what's volumetric efficiency? You've heard that term, right? You heard volumetric efficiency? Anybody know what it is? Can you guess?
Something to do with the cylinder pressures.
Correct. So it's basically, we know what size the cylinder is, right? So that has a volume, right? Your cubic inch or cubic centimeters, however you want to measure it. So ideally, they want to stuff as much air fuel combination in each of that cylinder every stroke that you can, and they can't really do that in all RPMs under all conditions. But ideally, you want to make the more volumetrically efficient an engine is, the more efficient and the more power it will make, and it also will be less from the emission standpoint. This is kind of why they're doing what we kind of came here to talk about tonight with the cylinder deactivation. What I talked about when we're running under light load, running down the road, you've got 8 cylinders that are firing and using fuel, but they're not really, you don't need them all because you got, you're only using a tiny little bit. So they've got everything pulled back, and the volumetric efficiency isn't very good at that, under those conditions, under light throttle, light load. So by shutting half the cylinders off, they make the other 4, on a V8 work harder, and they're much more volumetrically efficient when they're doing that. So they get better fuel economy, they have less emissions, which is the main goal of all this, right? And that's where they come up with the improved, the performance, right? Because of the better volumetric efficiency. That's
I'll
what
buy
they're
that.
doing. I'm just a salesman, all right? I don't have to believe everything, I'm just telling. So volumetric efficiency, I've already kind of just told you all this, but how efficiently it moves there. There's some mathematical stuff that you get on the internet if you want to read about volumetric efficiency. I'm not going to dig into that tonight, but I pretty much told you. That's how much fuel is required for efficient combustion is another way they talk about it, right? That's kind of what I just said, right? It improves everything. You got higher volumetric efficiency, improves fuel economy and performance. So again, fixed valve timing, they reduce it, right? So by using some of the tactics we were talking about earlier with phasers and stuff, they can improve it. So, any questions on volumetric efficiency or any of that stuff? That all pretty clear? It'll get a little more clear, I think, as we go forward. So real quick, I'm not going to spend a ton of time on this either, but it's part of the program, right? Emissions. So, vehicles are the #1 air polluter, all right? And then incomplete combustion is what they're trying to eliminate. So what are these harmful gases? I had them up on the screen here a while ago. Anybody know what these are? What are the big 4?
NOx,
Here are a couple of them. NOx, I heard. What was another one?
CO2,
Huh?
CO2.
CO2. What was another one? CO. Somebody said. What was the last one? NOx.
Hydrocarbons.
Hydrocarbons, right? Okay. Right there. Okay, so what are they? What are HCs? Anybody know? I know you guys don't do emissions testing here, do you? No. That's why. All right, and that's fine. I get it. I don't come from a place we did it either, but some parts of this country, dudes, these guys are all over this. They know it because they do it all day long, right? So, HCs, I'm gonna, unburned fuel. Somebody said it just as I clicked on it. So, unburned fuel or oil, imperfect combustion may not completely burn the fuel within the cylinder. Unburned fuel passes into the exhaust. It's bad, right? It's bad for people. What's CO? Carbon monoxide. You've heard that term. Kind of the same thing. Partially burned fuel or incomplete combustion, all right? So CO is an odorless, colorless, potentially lethal gas. This is stuff we were talking about earlier that kill you in your garage, right? And when CO is in a gasoline engine combines with oxygen, it leaves the engine in the form of CO2, carbon dioxide, right? Which is the next one. So that's again a colorless, odorless, non-flammable gas produced during the combustion process. When carbon and fuel combines with oxygen, it leaves the engine in the form of CO2. But one of the other things you need to know about that is CO2 is a byproduct that's produced when carbon from the fuel is fully oxidized during the combustion process. Generally, the higher the carbon dioxide reading, the more efficient the engine is operating. Okay? So air fuel imbalances, misfires, all this stuff, the bad stuff that happens usually cause the CO2, carbon dioxide, to decrease. So ideal combustion produces large amounts of CO2 and water. So you guys notice that mufflers now have water drains on them, right? There's a little hole in the mufflers to let the water out, right? Because why? This after treatment that we're doing to this exhaust that's coming out of the engine, we're turning a lot of that into water. Okay, so the last one is NOx, right? Anybody know how you get NOx? Where did it come from? high cylinder temperatures, right? So when you got excessive combustion chamber temperatures above 2,500 degrees Fahrenheit, the nitrogen combines with the oxygen, forms NOx at high temperatures, and when NOx is exposed to sunlight combined with unburned HCs, guess what? It creates that air pollutant known as smog. So NOx is bad. Any questions on that? We're not going to talk much more about that all. So, but again, you know, EGR is one of the purposes of EGR is to cool the combustion chamber down to try to help defeat NOx. All right. Let's talk about the actual cylinder deactivation. All right. So the story is cylinder deactivation shuts down these cylinders during low engine load. We already established that earlier, right? It doesn't, like I mentioned earlier, I think I said this earlier, no, it doesn't do the starting, idle, medium, or heavy throttle. It's only under light throttle conditions. Like I told you, there's a lot of redundant stuff in here. So what it does, it'll actually stop the fuel delivery to selective cylinders and disable the intake and exhaust valves. So this is the stuff you guys have run into, right? So V8, GM V8 engine, it's got this system on it. What cylinders do they shut down? What cylinder numbers did they shut down?
I think it's 1, 3, 5, and 7.
1, 3, 5, and 7, right? So you got the front one, and the back one on one bank, you got the center two on the other bank. Anybody ever had these apart? No. Ever notice anything weird about them? If you take one apart, if you've seen one of these engines, you know, are the cylinders that tend to deactivate look any different when you pull the heads off to do the lifters?
The lifters, yeah.
Well, all right. So, but have you ever noticed like a carbon or you know, is there a physical appearance difference in these cylinders or anything? They look different, maybe, right? And it might be different from engine to engine and vehicle to vehicle, but there might be times, and it's going to depend on how people drive it and all that stuff. But if you think about it, right? So some of them cylinders are working all the time, some of them cylinders aren't, right? So you can imagine there could be some different buildup between, could be some oil in there, carbon, whatever. So you've noticed that maybe?
A little more wear on the cylinder.
Could be.
Does it shut down ignition too?
I'm sorry?
Does it shut down ignition too?
It does not. It does leave the ignition run, but it does shut the fuel off. It's a perfect segue into where I'm going right here. So, deactivating the cylinder reduces the amount of fuel required to propel the vehicle down the road. I mean, the whole point of this, we were trying to save fuel, right? So, obviously, if we shut these cylinders off, we don't want to put fuel in there, do we? All right. They use two different systems, and we're going to talk about it. Most of the ones that you guys have seen, they were calling the active fuel management. The 1, 3, 5, 7. Is that it?
Yeah.
1, 2, 3, 4. 1, 4, 6, 7. Been a long day. And then this one we're going to talk about later. They actually can shut down all of them at any kind of random. We're going to get into that. Those are the new ones. So again, it always shuts down the same cylinders. Because we've already established that. Now, has anybody run any of the V6 stuff? We have some V6s out there. We even have some 4-cylinders out there that do cylinder deactivation.
Once.
You worked on one?
6-cylinder one.
Was there an issue with the valve trains part of it, or was it just something you just noticed?
The
It was
electronical part of it.
okay. So electronically, it had some.
Electronical is the R&R the motor, and you check it out, and it was showing a misfire, and you go back to the base, back coil, about this for injector, and it wasn't. It was in the wiring harness.
Okay.
For that dynamic.
But you didn't really have any
I didn't
we
have to go internally. No.
nothing with like we got with the V8 stuff,
Right, yeah.
So we'll talk about that. I won't spend a ton of time on that, but I'll show you how those work. It's kind of they got some good graphics on how that works, animation. We're gonna spend most of the time talking about the V8 stuff. But so 2 cylinders, the center 2 on the V6s are shut off when they do it, and they do the center 2 cylinders on the 4 cylinders when they do that. They do the ones we've been talking about. 1, 4, 6, and 7. All right, so, again, they do on the dynamic ones, they can operate on as low as 2 cylinders. We're gonna get into that a little, that's kind of a little preview of what we'll talk about later. All right, so electrically, I'm not gonna spend a ton of time on it. You guys see much trouble with the electronic side of this. It's all the mechanical side, right? No brainers here, right? We deactivate cylinder, the ECM deactivates the fuel injector, but it leaves the driver open, right? So we typically got a fuse running those types of injectors, and the ECM grounds them to fire them. You guys, there's no big deal on that. But then they also disable the intake and exhaust valves using specially designed collapsible lifters. These are the ones you guys have probably seen, all right? Anybody here not seen these? All right. Okay. So, this is the part I want to talk about. So, has anybody ever had any of these lifters apart, know how they work?
Not very well.
All right, well, we're going to talk about that. That's why we're here. All right. So if you can see this, I'll try to stay out of the way. It might be kind of hard. I think most of you guys should be able to see it. So it's a pretty big screen today. So how does it work? All right. So there's this collapsible lifter. There's an outer body which has the roller in it that runs on the cam. All right. Then there's an inner pin housing, they call it, in there that the push rod sits in. There's actually 2 locking pins in there with a spring in between. So there's a spring forces these pins out, and that typically that's the way it's always going to be. When the engine's running in 8-cylinder mode, those pins are going to be locked. It locks together just like a regular lifter. So you got your oil coming in like you always would. You know, you have in your old days, right? This is your hydraulic lifter oil passageway that puts the hydraulic oil in your lifter like any other, in your standard lifters and also in these lifters, right? But you'll notice there's another passageway down here. So, we've got another passageway in here that puts pressure, oil pressure. Those are the solenoids that are mounted on that V-loom underneath the intake. You know what I'm talking about? Got a V-loom with housing there. There's 4 solenoids there. When they go to each cylinder we've been talking about. Cylinder 1, 2, or 1, 4, 6, and 7, right? So when that oil pressure, those solenoids turn on, it allows oil to go into that passage. And that oil pressure will push in on those pins and separate it, right? And now allows this to do that, right? It allows that, when this goes in, now that center part that the push rod is sitting on just stays put, and the outer body will fly up and down on top of the camshaft and the valves won't open. The push rod will stay put, and the cam will just keep on running, and those pins will stay in there as long as the oil pressure stays in. As soon as they shut the oil pressure off to that, the spring pushes the pins back out and engages the cam. That's how it's supposed to work. Okay? So let me ask a couple questions a little bit. When do they do this? As far as in the suck, squeeze, bang, blow that we talked about earlier. Do you think that the time, or they just blow all the oil pressure out there? Is there a certain time they do it? What do you think happens? What's supposed to happen?
We just talked about it, at a certain load range and what it went to see.
Okay, I get that. But at some point, the ECM is controlling those solenoids, right, that are under the intake. It's going to say turn on.
I'm guessing top dead center.
Top dead center. Well, you got 2 top dead centers. We're talking suck, squeeze, bang, blow. What's top dead center you're talking about?
For that cylinder.
Top dead center on compression?
Yeah.
All right, so let's think about this.
I would say
They're on the intake valve, so it ain't letting air or fuel back into the system.
Well, let me ask this question. So, how many, you guys have taken these engines apart? Is this collapsible lifters on both the intake and the exhaust?
No.
It isn't? I think it is. It's
Yeah.
just, there's 8 of them in there, and they're on both cylinders, so both push rods are stopped, right? Am I agreeing? So whenever it happens, we're going to not open either valve once we deactivate the cylinder. Is that the way you're thinking about it in your head? both those lifters are collapsed if it's working correctly. Okay? So let's think about that. If you're running down the road, like throttle, like we're talking about, and decide to kick them on, so what is, if you close both those valves and don't open, the piston rod's still moving, right? So what's gonna happen? Isn't that piston gonna be sucking down on there, and what's gonna happen? Isn't it gonna want to try to suck all this oil right up past it? I mean, it's like a hypodermic, right? Don't you think it'd burn a lot of oil almost immediately?
Yeah.
So how they doing?
Even.
Huh?
They're leaving the compression stroke in.
So you've also looked at this. How many solenoids are there? 4. 1 for each cylinder. If you looked at the wiring on there, when it hits, that solenoid hits, it's dumping the oil to both lifters on each cylinder, right? So it's doing it at the same time. What do you think?
Just opens both of them slightly.
So, what was that?
I said it just opens both slightly.
But let's think about the problem we were talking about. If we did this when the cylinder is completely empty, the valves are closed, there's nothing in there, and then that piston goes, it's like a top dead center, like you were saying, right? Valves are closed, let's say, and you fire it, and then that piston goes down. I mean, it's going to be, if there's nothing in there, it's like a vacuum. You pushed everything out, and then you close the valves and don't open them again. It's going to draw a bunch of oil in. Also, how do rings work? If we think about it, don't the rings kind of rely on compression? They kind of push the rings out. The compression goes down around the top of the ring and keeps it tight against the cylinder wall. So that there again, if you take all the compression away, what's going to keep it from just drawing a bunch of oil in? So let me ask you this. What if they did it on, and I'm jumping ahead here.
That was a shitty design at the get-go. I just want to fix it.
Ah, you gotta learn how it works before you can fix it. Come on now.
Oh, no, they make kids
Stick
that
with
make
me.
all this crap.
That's what the
Awesome.
Summit catalog's for.
Put all new lifters in it, get rid of damn cans.
No, I'm talking about
Make it
it.
run good.
I'm just telling you, look, all right, I'm not gonna argue with you, I'm not gonna argue with you, but here's the deal. There are parts of this world, parts of this country, that they cannot defeat this. They have to fix it.
Like California.
Because they get emissions testing. And those guys, you know what, those guys fix it. Those guys fix it. So, are they smarter than you guys? Or, I'm just saying, I don't think you are. I've talked to those guys, they're not that smart, to be honest with you. You guys are just as smart as those guys
I'm not
are.
the best part.
So, I understand where you're coming from, and I don't disagree with you. I'm just a messenger here. But I am, I want you to understand. I think if you
I'm going
understand,
down to Mexico to pick up VW Buds
We're-
for 2,000.
where we're going with this, so that-
So I gotta worry about it.
when you start looking at this thing, it makes a lot more sense to you. I want you to successfully fix this stuff, is what I'm after, right? So if I get this, get you to understand exactly what's happening, then it makes it a hell of a lot easier for you guys to do your job and do it right.
Well, we all
right?
don't know, so just tell us.
I'm not just running this stuff through your head because I think you guys are smart enough to start to figure it out. All right, so these solenoids are mounted in there. And okay, one more. Right here. Here's the answer. Both lifters receive the oil at the same time. The exhaust lifter collapses before the intake lifter because the ECM commands the activation during the intake stroke. All right, let's think about that for a minute. So the intake stroke, what's happening, that valve's starting to open already, okay? So now that push rod's already loaded. Those little pins that I showed you earlier, they're already locked. So even though the oil pressure goes in there, it can't deactivate the intake one. It deactivates the exhaust because there's no load on the exhaust, all right? So what happens? So the intake goes ahead and opens, draws it in the fuel, fires it, and then never leaves it out.
You
right?
finally solved the mystery why they keep failing.
Well, wait a minute, but here's the reason they do that. They leave that last combustion event inside that cylinder to do what? It's gonna keep the rings tight against the cylinders. It's also gonna keep the piston quiet, right? Because if that piston's just flopping around in there, there's nothing on top of it, it's gonna be making all kind of racket, you know, and then again, it's gonna consume a bunch of oil. But how long will that stay in there? You know, even though you trap that in there, all right, it's going to keep it, you know, it helps with balance, it helps with a lot of other things. But it's still, even though the valves are it's still firing, somebody asked me that earlier, so it's still going to fire the spark plug. The main reason it still fires the spark plug even when the cylinder shut, you know, the valve shut, it, in case it does get oil in there, it doesn't foul it, right? You can go ahead and do it. But they basically can only keep it deactivated for a period of time because eventually you're going to lose it, right? That cylinder can't maintain that little last firing event in there forever. It can only do it so long. So that's kind of one of the deficiencies of this, right? Is that they can only run that cylinder in, you know, run these in deactivation mode for a period of time. Then it's got to come out and take a grasp of air, right? It's got to take another cycle and then refire it again. So that's kind of going on. Make any sense?
It's all becoming clear.
So does computer count the revolutions then?
Yeah.
And will automatically?
Yeah,
reset itself after
it's
so
right.
long?
So it's calculating how long it can, you know, somebody programmed how long they can run in deactivation mode. So for example, somebody gets out here on I-70 every day and they're running it in the mode where it's right when it's going to kick in. It goes into 4-cylinder mode. You know, it's going to run a certain amount of time. It may even do it fairly quickly. It may only fire, you know, another once or twice or something, and then repressurize the cylinder, grab the cylinder, and then go again. But they have to do the thing I was talking about earlier with the carbon buildup stuff. Somebody runs it in 4-cylinder mode quite a bit. I mean, you got to think about what's happening temperature-wise across that cylinder head, right? The cylinder, the one side, you got center 2 cylinders aren't firing, right? The other bank, you got the outer 2 cylinders aren't firing. What's that doing from engine temperature standpoint? There's a lot of things that are going on, right? You can. Well, I mean, yeah, again, they've all calculated all this. They kind of take this all into account. But it's not the ideal deal. The reason I'm bringing all this up is we get into the dynamic side of it, you'll understand why they're doing what they're doing with that versus this.
And engineers don't make mistakes.
Oh, yeah.
We already know that.
I work with a ton of
Don't make
them.
a tool.
Some of them aren't very smart
Make
at
a tool
all.
to fix this.
Some of them are, some of them aren't. You guys know which ones aren't, but I'm working on this stuff. But, so, but it's timing, right? So they have to time that. The other thing, so this has to be ideally timed so that it doesn't crash. So what you guys run into typically are going to be a crash scenario, right? Or that timing that I just mentioned was pretty critical. It has to happen on that intake stroke. If there's some reason it doesn't happen exactly when it's supposed to, guess what happens? These pins aren't completely engaged or they aren't completely disengaged, and that's when you get them. You got to figure there's a lot of, there's pretty tight tolerances inside lifters, right? If you've ever had any apart, right? So you get any kind of a burr or anything in there. What about debris? When you take these things apart, how clean are they? Everybody changes their oil just like when they're supposed to, right?
Every 25
Yeah,
miles.
yeah, right. So when you take these things apart, what are you running into? What are you seeing, right? I mean, I asked earlier about the combustion chamber stuff, but what about oil passages? What do you do when you repair them? How far do you go? What's your typical thing? You just fix the lifters that are failed and just put them back together? Do you put all of them in them? What do you guys typically do?
Usually so bad, you put lifters and camshaft there.
Maybe camshaft. So when you're doing that, how far apart? I mean, you taking the pan off, clean the pan out, you blowing out oil passages. What are you doing?
Brake cleaning, oil passages, a little bit of air.
Okay,
Lots and lots and lots of things.
lots of brake clean. All right, we're gonna. I get towards the end here. I'm gonna show you the way GM's actually saying now to fix them. So, all right. So I mean, is this kind of making sense now? They're doing it on the intake stroke. So the exhaust valve gets deactivated before the intake. The intake goes ahead and open, and then once it closes, it does that last firing event, keeps that combustion in that chamber to keep it from burning, sucking oil. And but if it doesn't, if that oil flow is not there, if your oil pressure is low, what would that do? Well, how would that affect your timing?
Shears the pin every time.
Yeah. Yeah. So has anybody ever taken any of these apart? When you take them apart, have you found like the V-loom bolts loose? Anybody ever had that? Four of the bolts that hold the aluminum
Yeah.
cover with solenoids there. Did you ever notice the bolts were loose?
Yeah, I've had some hand
Just put an
tight.
air ratchet or something on there and taking them off.
Yeah, I've had a finger tight before.
Right. So what do you think's happening there?
Oh, probably lift from all the pressure in there. I don't know.
You got to figure what's happening is a heat cycle.
Right.
The gasket starts to collapse, all right, and the bolts tend to start to get loose. Well, once that starts to get loose, what's that going to that oil pressure that's feeding that passageway?
Yeah, it's
That,
better off.
all the pressure that's supposed to be going there is going where?
Into the valley.
Into the valley, right? Outside, squirting out between that.
Stanchion and the VLOM.
Exactly.
Yeah.
Exactly. So you may be fixing the root cause of what's actually causing your mistimed event that's failing the lifters by putting the branding. You guys put V-looms on them when you do them? You check them? What do you do?
Place them.
Place them.
Just replace
That's what I would
them.
do.
Yeah.
That's what I would do.
Along with the high volume, high pressure pump.
Pumps, we're going to talk about pumps in a little bit, but we're kind of jumping ahead. But I'm just, again, trying to get you guys to think about it, all right? Yeah, now this is going to tell you the same stuff that we've just been talking about, so let me jump through this. Why is gas charge after the cylinder? I just talked about that. You want that small amount of drag during compression, reduces vibration, and keeps it from the tension on the ring so that it doesn't burn low. All right, again, I mentioned this earlier, spark plug continued to fire, keeps it from fouling. Fuel injection obviously shut off because we don't want to do that. We've got, we're not opening the valves anyhow. Again, we're trying to improve fuel economy. All right. I don't usually spend much time on this. You guys realize that when it goes into 4-cylinder mode, it really makes a weird noise in the exhaust system, or can. They fought that early on, and they did some funky stuff with exhaust, electric valves on the exhaust systems. Most people just don't even care. I mean, you guys run into any of that? You deal with much of that? If not, I'm kind of skip through this. You understand it's on there, right?
Here in Missouri, we
That's
just
what
put a
it's
test
for.
pipe in.
They put that on there because people don't like the droning noise when it goes into 4-cylinder mode, right? So they try to alleviate that with this exhaust flow valve control system. Is everybody familiar with that? Undesirable exhaust noises. You guys don't care much about it. We're going to kind of breeze on. All right. So let's talk about you guys probably know a lot of this. We talked about this earlier. Here's all the stuff it's going to look at to determine load, right? I'll go ahead and blow through this. So, oops. Let me just put that up there. So again, this is some of the stuff. I know some of you guys are talking, deactivate it or whatever, by calibration or whatever you do. To me, if I wanted to shut it off, I would find one of these things right here, fake it, make it so it will never go into AFM if some of this stuff, this is required, the stuff that it has to see in order for it to go into it, right? But it will enable AFM. All these factors have to be there before it will actually engage 4-cylinder mode, right? If something's missing, it won't go in. All right, and these are more. So you run through that. Map sensors out of range, engine coolant temperature out of range, vacuum out of range, brake booster vacuum out of range, transmission incorrect gear, throttle pedal out of range, engine oil pressure, temperature out of range, vehicle speed out of range, engine speed out of range. Minimum time in V8 mode not met. Maximum cylinder deactivation time exceeded. Remember we talked about that, right? How long can it stay in? D-cell fuel cutoff is active, all this stuff. Piston protective action because not detected, all that stuff will disable or not allowed to enable into AFM, right?
So basically, a car with a lot of miles, you can have 2 or 3 problems and not activate it.
What was that?
So a car with a lot of miles, like a Yukon,
Okay.
you can have a catalytic bad, speed
Certain
bad.
codes, if it's got certain codes in it, it won't go into 4-cylinder.
Okay.
You know, and you know, you gotta look at whatever the criteria on the code, whatever that code happens to be, and I don't know, I've never looked to see what they are, but it could be some catalyst deficiency code. Could be one of the requirements that if it has that code, you know, you just say under the codes, action taken when code sets, could be it won't go into 4-cylinder mode. I don't know. If you're right, some of the codes that it can set will keep it from going in. So, we're gonna skip through this deal here as well. We've already kind of talked about it. But here's the guys that aren't sure how that all works. That's the oil pressure. You get your oil pump up front, right? Oil pump's in the front of the timing cover. Runs back the side of the block. The oil filters on these things are typically on the pad, right? Runs through the pan and goes up the back of the block, goes into up to the back where the little filter is. You guys familiar with that little filter and the pressure sensor on the back of the V-load? Did you ever take that filter out and look at it?
Yes. Every time we change.
All right, so what if you got stuff in there?
Everywhere else.
Well, first question I would have is what is it, right? Is it metal? Is it just sludge? What's in there? Because if it's kind of like metal debris, I'd be stopping right there, figuring out where that's coming from, because you ain't gonna have a happy engine at all, if that's what it is. But, you know, if it's, you know, like carbon debris or sludge kind of stuff, you better, I mean, that's just a signal of what's going, you know, it's already gotten past the filter, somewhere else in the engine coming up through there. And just by cleaning that filter probably isn't gonna fix your problem, right? You're gonna have to figure out what it is and clean it out. That's why I was asking earlier about what do you guys do when you clean. And I got a video later that kind of goes through that. But here's, you know, what's going on. So that this way this is running, they got the oil pressure out here on that V-load, and if it runs again, if I hit the button again, it ends up, once it activates, then it runs that oil. It's hard to see here without running, but it feeds it out to those lifters that we were talking about. Like I said, we got deactivation lifters there, and number 7, right? 1, 4, 6, 7. All right. There's the solenoids. The V-load that we already talked about. You know, there's where they're at. There actually are 2 designs out there. I don't know if everybody noticed that, but they're interchangeable. There was 2 different suppliers actually is what it was that actually made these. They work the same, they're interchangeable. It doesn't matter if you have one design, you put the other design on, it doesn't matter, they work. The only difference that I know of is the gaskets are different, but you get the gasket with them anyhow. So as long as you never try to mess slipping the gaskets around or whatever, you'll never have a problem. But it's kind of something to know, I guess. There are two different types. And again, I just talked about that sensor and the filter, right? And this again, kind of redundant. It's telling you the same thing. It throws through the solenoids out to collapsible lifters. And then your pressure, they're typically looking around minimum of 25 PSI, even hot, is what you've got to have to activate those lifters without a problem. And you can't have any, you know, leaks anywhere.
Then why do they say 15 pounds of oil pressure is acceptable in idle?
Well, that's an idle. Is it going to go into deactivation mode at idle?
No.
So, but when you start revving it up, that pressure bit. So if you got to have at least 15 at idle, what they're assuming is if you got that much at idle,
I don't know. By the time they get to me, they don't come up anymore with the throttle.
Okay. Well, you know, you got to have the oil pressure to make this work, right?
Yes.
So again, this is kind of redundant. It's showing you the pins there. You know, with the springs on, you know which ones they are. Let me get through this here a little bit so I get to where I need to go here next. The guides, everybody's familiar with the guides, right? You can't really put them together wrong, right? The lifters, the collapsible lifters only fit on one side. The other style goes in the other side. You know, if you can't figure that out, you shouldn't be working on it. All right, so let me get through this. They put all this in here, but they mix in good stuff in with some of the redundant stuff, so I gotta kind of go through this. Again, it lines it all up like we know. Stick with me. So anyhow, I mean, I guess I didn't really talk about that. So the solenoids, I think you kind of understand that. They're normally closed, so that oil goes into that and stops at the solenoid when you're running the engine in 8-cylinder mode. And then when it activates, it opens the solenoid, which allows the oil to go through, which sends it out to deactivate the lifter, collapse the pins, right? So they're normally closed. There's the electrical side of it, which nobody really has any trouble with. So I'm going to pass through this. And again, it's kind of redundant, so hang with me. Okay, where I need to go, I'm almost there. I think it's the next frame. There we go. Here's where I want to go next. All right. So we talked earlier about the V6 stuff, right? So these are some of the engines, RPOs if you care. LGX, LGZ, LGW, and LGY. I think there may be more now. But cylinders 2 and 5, right? So there's a graph or animation there that kind of shows it. But they go from V6 to V4 and back, right? Just like the V8 would do. Doesn't seem like I've been all over the country doing this. I've not really had anybody other than you mentioned you had an electrical problem with one, but with the mechanical side of this, these don't seem to fail. I'm going to show you how these work, and you'll probably start to understand why these ones are okay and the V8 ones have the trouble. All right, because it's different. It works the same way. They use the same theory. Exactly. They're doing it. They're going to activate them on the during the intake stroke, just like the others, but they don't miss time like the V8s do. So let me kind of run through this real quick, just to give you guys an idea in case you do run into one and be familiar with it. And I'll show you the 4-cylinder stuff here at the end. But it's the same stuff, same components that we've been talking about. But there's this rocker arm. And stick with me here, I'll show you an animation of this. It's pretty cool that actually shows it. This is what these rocker arms look like. So they're spring loaded. You know, you notice those V8 lifters have springs on them. These have springs on them as well. All right. And there's an internal latching pin in here. And it's a little bit hard to see, but I got some better pictures coming up that actually lock it when it's working and then unlock it when it deactivates, right? Because you don't really have, you know, the roller lifter.
So the lifter's not,
It's a rocker that deactivates, correct? Yeah. So again, they're gonna same kind of deal. It's gonna be spring activated mechanically whenever it's latched and you're in V6 mode, and then they're gonna use oil pressure just like we do with the V8s to release it when they want it to release, right? So let me get into so the solenoids, we got a V-lobe and the V8. Well, we got individual solenoids on this, is the way they've got it, right? So you've got, you know, 2 of them, one on each bank, that actually direct the oil to those switching rockers, right? It's the same kind of deal. You're going to disable both rockers on that center cylinder on each bank. So it kind of gives you a description here of how they go about that, but and shows this. You have your oil from the engine, if you can see it there, and then it goes into that switching gallery, and it's got a little better. Like I said, there's a video coming up here that actually shows it really well. So that's where those deactivation solenoids are on the V6. It's right on the cam cover. Of course, adjusters they're a different height for those ones versus the standard ones. There's what they look like. And then I want to get into, you know, cam carrier. I mean, it's just showing you where the passages are on that. But I think right after this is the animation I'm looking for. Get it to it right Come on. Once I get the end, there it is, there it is. So this is, pretty good graphics, actually better than the V8 stuff we got, as far as how it works, right? So you see your overhead cam on the top, there's that switching rocker that we're talking about. You get your follower, of course the valve and the spring, and there's your active solenoid. So there's your oil pressure coming in. Of course, it's feeding it just like it would before, typically, but then it's also got a separate passage coming from the solenoid, so when the pressure's low, it opens the valve. As it comes around, boom, that rocker's one piece basically, it opens the valve just like normal. Boom, you throw the oil pressure in it, now the oil pressure goes in through that follower, or the stand, it goes up in and pushes that pin back. You can see it at the top. Now that's unlatched, and now when that cam comes around, there's nothing to hold it. It just drops against that spring that's in the middle of that rocker, and it just follows it. It follows the camshaft, it doesn't open the valve. That's how they do it. These things don't seem to fail. You don't have much passageway or anything. It's a lot more positive deal. If you think about those pins and the clearance and everything in the V8 ones, right? You've got that cylinder inside of a cylinder inside that lifter that's sliding up and down, and you've got the pins in them little holes. And if it's mistimed, you've got, everything's got to be lined up perfectly. This here is a lot more forgiving, right? If something would get mistimed a little bit, I don't think you're going to have a jam up like you do with your V8 lifters. That's what happens to those. Those shelves, the surfaces that those pins, lock into, if it starts to burr, now them two pieces of that lifter can't move against each other, and that's what locks them up, and that's what you guys find when you take it apart. Lifter's all jammed up, the spring's all collapsed. That's what's going on. It's a mistimed event that's actually causing that stuff to not activate at the right time, and as soon as it starts to burn up, you got trouble. All right?
When did they start coming out with these rockers?
These?
Yeah.
It's probably about the same time we did the V8 stuff. Early 2000s, probably, or late 2000s, I guess it was.
Okay.
You can look at those RPO codes I had on there. If you Google that, you can probably see what years they were built. I'm not sure.
So it's all the Alloy Tech stuff, pretty much.
They've been out there a while. Yeah, there's a lot. Those RPO codes have been out there, I know, for a while. All right. So that's kind of the active fuel management. We're going to come back to it a little bit, but I want to talk about the dynamic side. All right. So around 2019, they went to a different style. What do you notice about these? You don't see a V-lobe on there anymore. What do you got?
The solenoids.
8 individual solenoids. It can deactivate any combination of cylinders. So go back to what I was talking about earlier with the temperatures across the cylinder heads, how long that is deactivated, you're trying to deactivate that same cylinder. If you have the ability to just bounce around that engine and just do this cylinder for a little bit, this cylinder for a little bit, keep going, and it keeps everything temperature-wise heated the same. They run the same amount of, possibly, carbon buildup in each cylinder. It's a lot better system. And they can, instead of having to just either V8 or 4-cylinder or nothing in between, now they got the ability, they can shut down certain cylinders at certain times, multiples. They can get clear down, they claim they can get clear down to 2 cylinders for fire if it gets under the right conditions. But it might be 6, it might be 5 even, it might be whatever. They make all kind of different. So this basically is coming down to the ability, the faster computers and stuff that are on the newer vehicles are able to do this. The older stuff, this all they could do is do the 4 on, 4 off type of situation. Well, different types of firing orders, they've got different, like I said, fixed patterns and some that are rotating, and can deactivate any cylinder anytime, like I already said. Like I said, this gets kind of redundant. So again, what's the advantages are, we just talked about. They both use collapsible lifters, but the AFM uses a V-lobe with 4 solenoids and 8 collapsible lifters. The DFM uses 8 solenoids and 16 collapsible lifters. And the AFM deactivates the same cylinders all the time. Well, you can do any of them with the DFM. And again, that DFM can stay in deactivation mode longer without the risk of oil buildup in the cylinders. That's probably the biggest thing they're doing this with.
Are they still using the same style lifter?
I was gonna ask the same thing,
Yeah.
that's what I was wondering.
I believe so.
Wow, okay.
I was hoping you'd say, no, they upgraded those.
I mean, they've always gone along and tried to make it, it's really not the fault of the lifter that's failing them. It's that timing. If it doesn't matter what quality of lifter you got there, if that thing is trying to, the pin's not completely engaged and the pin's, partially disengaged or whatever, and it starts to burr. There's actually some pictures, I think that picture's a little later on, it shows when they cut them apart and looked at them. You guys ever take any of them lifters apart? You have?
Yeah, it's
What'd you find in there?
It's just, it's a galled up mess.
Right, it's all galled, right? So it's usually right there on that shelf where the pins go. It starts to burr that, rounds it
Yeah.
over basically, and then that starts hanging it.
Yeah,
And then once it hangs, and then then the lifter, once it hangs tight, now the push rod gets loose and it's a wreck, right? It happens pretty fast.
Yeah.
So again, there's all kinds of different failures, but that's mostly what you end up seeing.
I always assumed, or have been, from my understanding, it's an oil issue.
Well, we're going to talk about it. You're jumping ahead a little bit, but we're going to talk about the type of oil. You guys, the Dexos oil. So are people using the right oil in all these engines all the time? How many people are checking their oil? So what would happen on this deal if the oil gets low? Right? So what were we talking about? You got potential of when it's in 4-cylinder mode, it can actually suck oil into the engine, actually use oil in 4-cylinder mode, right? Into the right conditions. So now the oil sump gets low. Of course, the guy's not checking it, right? So he doesn't realize it's low. What happens if this thing sucks air? If this system's got air in it and you try to activate those lifters, what's going to happen? It's going to be bad, right? So it could have been a low oil pressure or low oil level, actually, that was the root cause of whatever the failure was.
When did this, all eight solenoids come
Around
out?
19, I'm going to get into that
Okay.
a little deeper here in a minute. And you'll probably like what I'm going to say.
I just hear money bell. That's all I hear.
So again, it's telling you again, there's a lot of redundancy in here. Solenoids the same way, it works pretty much the same way, except now we've got 8 of them, and it's a different control. The ECM's faster, and it's got a different strategy than the old system did, the old AFM. All right. So the enable criteria is pretty much the same, the list that we had earlier, if you were paying attention or took a picture of it or whatever.
What is that oil aeration mode?
So same kind of deal. If it takes, was it a high RPM or something that there could have been air in it, then, under certain conditions, they'll.
How does it know that if it's
Basically the criteria of what, the ECM knows what the engine's been doing.
The probabilities.
Yeah, it's a probability type thing, that there's a possibility that you could have aerated the oil, so they'll try to cycle it before it does its activation in case there was air in there. They don't know if there's air in there, they
Okay.
think it might be. It's a strategy that's programmed into it.
all right?
All right. So this is, again, it's telling you the same thing. So control styles is a little bit different than the other one. The other one it was fused power and they were controlling the ground. And this one, they're actually controlling both the power and the ground with ECM. About the only difference in this.
It's so much easier.
Well, it is. You got better control over it. It's the same stuff. It's got the same. The only difference is the path. Now we don't have that V-loom, so the passages are all in the block now. We don't have that separate passage up in the lifter valley like we had before. So it's just got a separate passage. The blocks are different, obviously, and they run it. They got the solenoids are right in the block, so they can open. The pressure's in that block, and then as the solenoid opens, it feeds into the individual cylinder lifters that it needs it. There isn't a really good graphic on that here, but you can kind of picture it from the pictures, I believe. So, what about 4-cylinder? Anybody seen any of the 4-cylinders? There's some 4-cylinder turbos and stuff out there that actually go into deactivation mode.
My Earth Dreams motor doesn't, my Honda.
Yeah, well, they're doing it on rock arms, I believe, same way.
I know.
So these ones, what they're actually doing is they're moving the camshaft. So they've got, the camshaft is just basically a spline shaft, And then they've got these sleeves that have the lobes on it, that are on top of it. And then it's got like a manual transmission shift lever with D10s. And it's so, you can laugh, but they seem to fail. They don't seem to fail me. So this curved groove in there, this pinnacle in there, and you know, the solenoid's mounted in the valve cover, and then basically it slides that cam under, you know, where there's no lobe.
Just like a PTO.
Exactly. Like high load. They even got multi-loads. They got low lift, high lift, and no lift.
Okay.
So they can, all the lobes, you know, even the outer cylinders got a low lift and high lift cam lobe on them, and then the center ones have low lift, high lift, and no lift. So they can go anywhere from, you know, low range, mid range, high range, and also cylinder deactivation. They just keep moving the loads back and forth. So I don't have a lot of detail in this presentation on this, but that's kind of the way it works right there. 2 liter, 2.7 direct injected turbo engines have that system on them. We got another class on the valve train stuff that goes into this a lot more detail.
Do I see Volkswagen on the screen there?
Yeah.
Is that a Volkswagen engine that you showed us?
Yeah, the problem is that that's on YouTube, and that they're not really wanting me to go to YouTube. There is one video that I am going to show you that is on YouTube, but it's kind of embedded in here, so I'm allowed to do that one. But those ones, because when you go to YouTube now, you get advertisements, and some of those advertisements aren't.
AGM.
Yeah, right. Well, they're some of them. You know, you got some stuff that's inappropriate, right, on some of these on YouTube anymore. So they stopped us from going to YouTube in those cases. All right. So again, the diagnostics on this stuff isn't usually that tough. You guys can usually figure it out. We've already kind of talked about it. It's mostly all mechanical stuff, right? You're typically going to run into oil pressure related or oil feed related issues that are your root cause of what's going on. When you guys see it, it's already failed, right? You've already got some sort of mechanical problem with it. Then you got lifters jammed up, push rods bent, whatever's happened, all right? So let me run through this. I'm probably going to go through most of this until I get to a spot here I want to show you. The set codes. Stick with me. That's electrically. Let me look at this one real quick. Yeah, same thing. We've already kind of talked a lot of most of that stuff. One more, I believe. Nope, a lot. Here we go. This is where I want. All right, so let's talk a little more about the mechanical side of the V8 stuff. So there's your lifters. Actually, if you look at those pictures right there, that's probably something you've kind of seen. That one, get the spring all bound up on that one. That's probably jammed up. So the hydraulic and mechanical concerns for these. So sometimes they set codes. You probably run into that, right? Occasionally, there's a code in. It depends on how long somebody run. Did they run it? Did they have it towed in, or did they just drive it in and make it a racket? What depends on what they did, right? So if the lifter sticks in the collapsed position or a solenoid sticks in the open position, affected cylinder valves won't open or close, reducing the amount of air, yada, yada, yada. And then if it sticks the other way, it goes the other way. All right. So there's the pictures I was looking for. This is kind of what you're seeing. Can you see this damage right here? So you got to remember, you got a lifter. If you've ever had a hydraulic lifter apart, there's the piston inside of that main body of that lifter. It's very tight tolerance, really close. And if you start to burn that up, that's what jams them to where they quit moving internally. It'll break. So you can see that one's actually broken. So they actually get damaged from this time event. So lifter concerns are often caused by a condition called mistime switch event. Mistime switch event occurs when transition between valve states occurs late. All right, for many reasons. Caused by dirty oil, creating a buildup in an AFM or DFM hydraulic lifters, circuits, or devices. Okay? So, I am going to play this video here. Hopefully it comes up. Watch this.
Hi, I'm Jim Rokitsky for AC Delco. Today we'll focus on General Motors Active Fuel Management, or AFM, and replacing all AFM lifters in V8 applications. For V8 engines, AFM is used to switch the engine from 8-cylinder operation to 4-cylinder operation to save fuel under light load conditions, when the engine control module, or ECM, commands the AFM system on switching to V4 mode. The AFM system uses a valve lifter oil manifold, or V-loom. The V-loom delivers pressurized engine oil to 4 normally closed solenoids. Each solenoid regulates pressurized oil for the intake and exhaust lifters to deactivate selected cylinders 1, 4, 6, and 7. To deactivate AFM lifters, pressurized oil from the solenoid forces latching pins into the lifter body, allowing the outer portion to follow the camshaft load, while the inner portion remains stationary. To activate AFM lifters, the V-loom turns the solenoid off. As oil flow stops, spring pressure forces the latching pins out, locking the inner body to the outer body to engage the push rod. A mistimed switch event may result in AFM lifter failure. AC Delco has analyzed engines where lifters collapse due to a mistimed switch event. Witness marks show damage on the latching shelf of the lifter. This happens if the latch pin is not fully engaged at the time of the loading, and damages the edge of the outer body latch shelf. The inner body can become stuck inside the outer body, creating a collapsed lifter. If an AFM lifter is collapsed, low compression will be found on that cylinder during an AFM compression test, with a consistent valve spring tick noise, service engine tune light on, and misfires on the related cylinder. Valve lifter failure may be the result of a mistimed switching event, not the cause of it. Causes include low engine oil pressure. From improper engine oil levels, either too high or too low, can cause aeration of the oil. An internal leak in the V-loom, due to a failed solenoid or leaking gasket to the block. Sludge inside the engine, restricting oil flow through the V-loom filter screen. View oil pressure in the cylinder deactivation data list. Known good vehicles have around 25 psi, or 172 kPa, or greater at a hot idle. If the reading is 19 psi, or 131 kPa, or less at hot idle with new engine oil, inspect the V-loom filter screen located beneath the oil pressure sensor at the back of the V-loom. When replacing AFM lifters, clean the oil control passages in the engine block by blowing through them with shop air. If a lot of debris is noted, flush the passages with brake cleaner and change the engine oil and filter. Inspect the camshaft for worn lobes and scoring of lifter bores. Install AFM lifters into the guide by aligning the notched area of the guide with the tab of the lifter. Each guide holds 2 AFM lifters and 2 regular lifters. If any AFM lifters are unlocking or collapsed, replace the V-loom, all AFM lifters, all plastic lifter guides, and any other damaged components. Once again, I'm Jim Rokitsky for AC Delco. Thanks for watching.
All right. So what do you say? Put them all in there, right? The only thing he didn't say is put all the standard lifters. I wouldn't do it without putting all the standard lifters in. I wouldn't do it without putting a V-loom in it. They do show some V-loom tests in here. I wouldn't be testing a V-loom. They test it right in the garbage can, put another one on. It's not worth it. It's too much risk. You know, there's too many things that can be wrong with that thing that you're not going to be able to find in a test. You know, you put that thing all back together and it's got a problem. They're telling you right there from the factory, put a V-loom in it every time.
Can all of this have an effect like on the V8 5.3 with oil pressure problem?
Well-
Them five things that drive me nuts, it's oil pressure problem.
Well, right, so, like it said in there, right, low oil pressure, and it kind of mentioned the aeration in there. So if it's low or high, which high would make sense too, if it's overfilled, it's gonna whip it.
Whip it, yeah.
But, and low, it can, all it needs to do is draw some air. But what are you seeing as far as oil pressure problem? Pumps themselves, because we got variable displacement pumps now, right? You got, if you've seen, there's a solenoid on the pump now that they can vary the output of the pump. It's another strategy to try to save fuel economy, so they only pump as much, they don't over pump and bypass. That's what we used to do. We would make the pumps big enough to take any situation, but then bypass what you don't need. Well, that adds load to the engine that's not necessary. So if they can downsize the pump, I mean, they do with transmissions as well, right? Transmission pumps are variable output.
Speaking of the load, and your issue, whenever I have one of these oil pans off, I always remove that relief
Yep.
valve and stick a pipe thread plug in it. Every time I have one off. It doesn't.
Well, I put a new one in, and I don't know about plugging it.
Oh, I plug mine.
I didn't catch that.
It's the oil relief valve for the VLOM system, well, for the whole oiling system.
For the whole oiling system.
Yeah, and it's got the relief valve in the oil pan that relieves pressure. They fail all the time, and it causes big problems, so I always plug them. That's what all the...
I'm worried about plugging them. I mean, they're on there for, they got them on there for a reason. But I'm with you, if you gotta at least replace it when you're in there, probably the way I would work.
I'm sure they tell you to say that.
I mean, if you got, I guess what you're thinking, if you've got a high mileage motor's got a lot of miles on, the probably chances of having a problem is probably not that bad by plugging it.
Yeah, I mean, you're only hitting 40, 50 at cold.
Right.
So,
But if you've got a low mileage motor and you do that, you could get into some blow the oil filter off or something like that, right?
So this is in the oil pan, you said?
Yeah, there's there might be a picture in here.
yeah, it's
Actually,
way,
hang
way
on,
back
that's
there.
Videos of guys.
It might show it here.
I've never
I'm
done
trying
it,
to
found
forget.
out, heard people doing it, it's in the.
Yeah, it's going through the oil levels and that. Looking, here's what they're saying for oil pressure in this video. But this is a 2018 4.3. All right, now, some other engines got different specs on them. But they're saying at 1,000 RPM, a minimum of 22 PSI, 30 PSI at 2,000, 33 at 3,000. So that's a 5.3, 2021 5.3 and an 18 4.3. But that may not be the same for everything. You were mentioning before 15 or something? What did you say?
Yeah, in the book, yeah. I think
Was there a
one of them
spec
says-
on-
Yeah,
you remember what
one
year
of them
it was
says
or what
10
model?
11. I don't remember which one
Okay.
it was, but it's just ridiculous,
So here's what they're wanting for a maximum, 75 PSI at the V-loam.
Which,
That's at the oil pressure sensor at the back of the V-loam. Here's, where are you guys checking them at? Kind of like this, like where the oil filter goes on, or?
Yeah.
Mhm.
It's just quicker.
Yeah, it is. But I was looking to see if it's got that, we were talking about that, pressure relief valve. I think there's a picture in here of it. I'm gonna bypass V-loam testing because we're not doing that. Engine compression, well, I mean, they're talking about lifter failing, you're checking compression, but I think you guys are smart enough to figure out how to figure that out. So I'm gonna go through that. This is that exhaust control valve that nobody cares about, I'm gonna go by that. And then, hang on a second, I thought we had another deal in here, the oil pressure. I could be wrong. All right, let me do this. It's gotta be in here, if it's anywhere. I think we get back to it here in a minute. So again, we're looking at, filters, try to keep the oil clean, right? Air filters, oil filters, good maintenance, it's common sense, right? Oil filter, the correct oil level and quality prevents oil pressure related issues, right? Using the right oil and proper oil changes to kind of alleviate some of this, keep the debris from getting in there and jamming them up, right? Oil level, like we just mentioned, if it's too low, too high, it's gonna have problems. Mostly too low is probably what you're gonna see, right?
then the coolers.
There's another chunk in here that I definitely want to go through. Nope, I don't see it there. There's the filter. Checking about checking oil. That's costly. You just change your oil if you think there's a problem. Hang tight. Let's see. So here's some symptoms, right? This is all common sense stuff. Codes, could have codes, noise, aerated oil, low pressure warning lights. Verify the engine oil, verify oil pressure, check oil viscosity. That's actually done in some places here. I'm gonna go past that. Here's, oh, okay, this is where I thought we might have this, what you were talking about. I thought there was a picture in here of this. It might not be though.
You showed it way in the beginning with the oiling diagram with the VO.
Yeah. Low pressure rate indicates, here's all the stuff that causes with the low pressure, right? Anybody disagree with any of that? I don't. Contaminated oil, wrong viscosity, pump mounting bolts loose, pump screen, O-ring missing on the screen, I've seen that. You know, let's get the tube goes up into the pump from the bottom, I've seen that O-ring cutter on.
Yep.
Malfunctioning oil pump, there's a malfunctioning oil pump pressure relief valve.
The only thing I don't see up there is cam bearings.
Well, yeah, but you're right, that's another thing that could be.
Excessive bearing clearance, that is your cam bearing.
Yeah,
Okay.
well, there you go.
Engine
That's an
bearings.
engine bearing clearance, yeah.
That kind
I
of
did.
covers it.
everything, yeah.
That kind of covers everything. You didn't
One
change the oil, you
rear
put
oil
Pennzoil in it, we're done.
Malfunction oil bypass valve, oil pressure gauge, malfunction oil pressure sensor. These are all things that can do this. All right. There it is. That what you're talking about?
Yay!
I thought there was a picture in there. I knew I'd find it.
Yeah, standard
That's in the
pipe
pan.
thread fits right in there.
Says the oil pressure has led to the discovery of warped oil pans on some of them equipped with fleet vehicles and idle excessively, is what they're talking about here, but they're showing that valve that you're talking about. All right, so where I want to go from here is single-use fastener. You guys are aware of that, right? Don't use head bolts over.
They're one-time application.
That's right.
Each time I use it.
Torque to yield. Haven't changed the belts. I don't think you guys know about all that. So if you got one that blows up, got junk in it, intake and trap material in it. Don't put an exploded engine intake on a new engine. The debris will get back in the new engine.
No warranty.
Don't do that, all right? And the cleaning we already went through, we showed the video on that. There's one other piece here that I'm looking for that I want to show you guys. Again, this is all redundant. We went through this earlier. Well, two others. This is the other thing. So there is a tool. So remember I mentioned we got all the solenoids now that are actually in the block. So they found that these can be hard to get out of the block, believe it or not. Special tool to get that out, get that solenoid out of the block. So in the 2019 newer Silverado Sierras with 5.3, it may be challenging in a 5.3 or 6.2 to get those. If you do have to change a lift or a solenoid, it may be hard to get it out of the block. Yes, sir.
Hey, could you go back one so I
Yeah.
get the part number?
I'm sorry.
I just want that part number up.
Oh, the 5.7 Hemis, you just break the top off your hood.
Hang on a second.
Screw it in.
I gotta get there.
Slide hammer it out. That's the easiest way to get them out.
I think where you want is right.
It was right before that last page it was on.
Right before that.
I gotta get back to it though. It had the tool on it, yeah. All right, let me get it. Hang on. Right there it is, I see it. I can see it on here, but I might not be able to get it to come back up here.
Just shoot that part number.
So you look at that part number is EN Edward Nelson 52511. That's it. AFM OCV remover.
There you go. Thank
Oil
you.
control valve remover.
Is Chevy gonna keep them in stock for us when we get them?
National back order.
Parts counter? You gonna keep that parts in stock when we
we need one?
There it is. There, I got it. I got the one. That's what you're looking for, right? 52511. That tool. Everybody got that? Sorry about blowing through there. And then, yeah, there it is. That's the tool again right there. So that's how you end up getting it out of there. Slides over when rotates, secures to each coil for easier coil removal. All right, but what I want to get to, and we're going to skip over the exhaust valve stuff. I got one other. We're going to skip over the programming. Crank variation relearn. I don't know if you guys are really going to get into that much, but here's the one I want to show you. Okay, so unique vehicle builds. So we've been talking about this all night. We're pretty much done. So we had the active the AFM systems, right, that you guys are used to, and then it went to the DFMs that have all the solenoids on all the cylinders now. But if you guys recall, when COVID hit, which was when 2020, some vehicles are built with inactive AFM, DFM systems. So what it is, that if I actually go back here, see if I can go back and get it again, I can't skip past it. No, hang on. There it is.
Figure out if it had it, it's supposed to have it, but it didn't have it.
Right there, YK9. So what happened was, if you guys remember when COVID was in there on 2020, 2021, especially 2022, they were building vehicles and there was a chip shortage, right? If you remember, they were building vehicles and they would take them off the end of the assembly line and they would take modules out and go back and build new vehicles, and they were parking all these vehicles everywhere, whatever. So part of the chip shortage stuff was in some of the ECMs and stuff, they weren't able to put all the hardware into the ECMs to drive the variable displacement portions of the ECM. So they initially we're trying to get it enough that they could actually do this and put it all in there the way it was originally designed. They got an exemption, and GM wasn't the only one. Some of these manufacturers got exemptions, and the way they determined it was they ended up building ECMs that weren't able to operate the DFM. So all the hardware that we've been talking about is in the engine, but they never go into the cylinder deactivation mode. If it has, so what they end up having to do is create an RPO code to clarify which vehicles are disabled from the factory. So the story initially was that they were going to come back and recall them and pull them back in after they got the ECMs, but they got through the courts and everything. So I don't know exactly, the lawyers got involved or whatever happened, but they determined because they had these RPOs, the rule is from the feds is it's the way that it left the factory. So these vehicles actually left the factory disabled. They're never going to turn them on.
They bribed the EPA.
Well, somebody got rich, and I think. All right, so that's what they tell us. All right, but here's what I can think of. What would prevent them from actually, you get a service ECM. So these trucks go out, they drive around for X amount of years, and then the ECM goes bad or whatever. And somebody goes and gets a service ECM and puts it in there. Now the new ECMs that are on the shelf maybe have the software chips or whatever it needs to make it work. And then you got to reprogram it when you put it in there. Would it turn it back on? I asked that question specifically to an engineering guy. They said no. What? They said because that VIN number has that RPO code, they wouldn't ever turn it back on. That's a story I guess.
Well, that's what HP tuners is for.
So these are the good ones. These are the ones you're looking for. So when you Google looking for a truck, try to find with a YK9. I don't know. I mean, I haven't really heard of this DFM ones having the problem we had with the AFM. I think a lot of the problems that we had with that had to do with the V-loam and the way that oil was riding through there.
Yeah.
I think the fact that they went this direction, I think will help. I think that's going to be a lot. Now, will these things, if somebody doesn't change the oil, It gets dirty enough, could it jam it up? Yeah, it could. But I think you won't see it nearly as often as you did with the old one, my opinion on this. So, any questions on that? That's pretty much it. I'm gonna, there's case studies here that are kind of stupid I'm not gonna do.
Oh, that's the best part.
You wanna talk about them? There's one right there. All right.
Quick time.
Quick question.
Yeah, go
You
ahead.
said that the lifters really are failing because of the electronic part of it, the timing, right?
It's the mechanical timing of when it's occurring,
Gotcha.
correct, yeah.
So why are Rams 5.7, 6.4s, they're experiencing the same things? Are they not the same suppliers or? I know
Good
you're
question.
GM, but they're failing the same exact way. Lifters collapsing, taking out cams left and right.
One other manufacturer?
Mopar,
Yeah.
yeah.
Well, it's the same design. I mean, really what you're coming down to, the biggest problem we've got with the tool,
But are the lifters the same?
they might be, you know, I mean, you can't take the heavy one and put it in an LS.
Oh, yeah, yeah.
But they're, if you look at them, where the problem is between the two parts of that lifter, the outer body and the inner body. And in both cases, it's very tight tolerances, and they're using probably a very similar, I haven't looked at the heavy one, but I bet it works just about the same way. And it's gonna be the same issue, right? It's that timing issue of that pins going in and coming out. And if it's partially in, it's not completely latched or not completely unlatched, and that thing tries to lift it, that's when it jams up. All it does is it starts to burst, you know, it just takes a sharp edge and starts to muscle it over, and then that thing starts jamming up.
Fun, dude?
Or it gets debris.